Ever wondered how manufacturing companies ensure maximum productivity with minimum delay? The secret is line balancing. This is a production strategy that involves arranging a manufacturing line so that every worker has the same amount of work. The goal? To reduce production time and increase overall efficiency. It's all about optimizing workloads among different workstations in the production process. Each workstation is assigned a balanced amount of work, helping to eliminate bottlenecks and idle time. This way, companies can produce more goods in less time, saving resources and boosting their bottom lines. Line balancing is a critical part of lean manufacturing principles, aiming to minimize waste and maximize value. Whether it's the assembly line in an auto manufacturing plant or the packaging line in a food processing facility, line balancing plays a pivotal role in enhancing productivity. So, are you ready to dive deeper into the world of line balancing? Now, where do you think line balancing is applied in real-world scenarios? Let me tell you, it's practically everywhere. Take the automobile industry, for example. Here, line balancing is a key factor in ensuring a smooth assembly line operation. From attaching the tiniest screw to fitting the engine, every process is meticulously balanced to increase efficiency and reduce waste. But it doesn't stop there. The apparel industry also heavily relies on line balancing. Can you imagine the chaos if the person stitching the buttons is slower than the one sewing the seams? The entire production line would be thrown off balance, resulting in bottlenecks and inefficiencies. Here's a question for you. Can you think of any other industry where line balancing might be crucial? I bet some interesting answers are popping up in your minds right now. Let's move on to understand the challenges associated with line balancing. Line balancing sounds great, but it's not without its challenges, right? One of the most common obstacles is dealing with variable tasks. These are tasks where the time required to complete them can fluctuate, making it difficult to maintain a steady workflow. Another challenge is managing human factors. Workers are not robots, and their productivity can vary based on factors like fatigue, motivation, and skill level. This makes it hard to predict exactly how long a task will take, which can throw off the balance of the line. Then there's the issue of machine breakdowns. Even the most reliable machines can have off days, and when one machine in the line stops working, it can cause a domino effect that disrupts the entire production process. So here's the second question. What other challenges can you think of in line balancing? Now that we've understood the challenges, let's look at how we can analyze them. How do we go about analyzing and solving these line balancing challenges? Traditionally, line balancing has been approached through methods such as time and motion studies, where each operation's time is measured and analyzed. But these methods have limitations. They can be time-consuming, costly, and may not fully capture the complexities of a modern manufacturing line. Enter the world of manufacturing simulation or process simulation. This modern solution uses computer-based models to simulate and analyze production processes. It allows us to experiment with different configurations and scenarios without disrupting the actual production line. Now let's pause for a moment. Can you think of any other modern solutions for line balancing? Perhaps you're considering artificial intelligence or machine learning algorithms, which are indeed cutting-edge tools in this field. Let's wrap up by discussing the advantages of these modern solutions. They provide a more comprehensive analysis, save time and resources, and ultimately, they help us make more informed decisions to enhance efficiency and productivity. So, why should we move towards modern solutions like manufacturing simulation? You may wonder. Well, the answer is simple and multifaceted. Firstly, simulations provide a clear visual representation of the manufacturing line, making it easier to identify bottlenecks and inefficiencies. Secondly, they offer more accurate predictions of outcomes, helping to prevent costly mistakes before they occur. Lastly, simulations bring increased flexibility. They allow you to test different scenarios and strategies without disrupting the actual production line, making it a powerful tool for continuous improvement. Now, I encourage you to ponder these questions. What other advantages can you think of, and how do you think this will change the future of manufacturing? That's all for today's video. In our next video, we will explore manpower planning and how manufacturing simulation supports it. Don't forget to like, share, and subscribe for more insightful content. And remember, your thoughts and ideas matter to us, so don't hesitate to leave a comment below.